Hello friends, welcome back to our channel. Today in part 3 of Mastering Parallel Programming series, we'll see another foundational framework for a structured parallelism, that is the parallel class. In the world of C# programming, efficiency is paramount. But what if we told you that you can turbocharge your code without complexity? Here the parallel class comes into the picture. We'll explore the powerhouse features of the parallel class, revealing its three essential static methods that bring structured parallelism to your fingertips. So before we get started, just a quick reminder to subscribe my channel, hit the red button and don't forget to click on the little bell icon. That way you'll be notified every time I upload a new video. Okay, without any further delay, let's get started. EFX components. If you have been following along with my previous videos in this series, you might recognize this diagram. Take a moment to glance at it. Here we have two structured data parallelism, P-link-Q, that is parallel link queue, and the parallel class. I have delved into P-link-Q extensively in previous videos, so if you haven't caught those yet, I highly recommend giving them a watch. Today, our focus shifts to the parallel class. Now, turning our attention to the diagram, you'll notice that the parallel class is a crucial component of the task parallel library, that is TPL. So today, we will be taking a deep dive into its capabilities and application. The parallel class in C#. Within PFX, the parallel class offers a foundational framework for a structured parallelism, featuring three essential static methods. See this diagram shown over here. Here there is a parallel class. It has three static methods: Parallel.Invoke, Parallel.For, Parallel.ForEach. What is Parallel.Invoke? It executes an array of delegates in parallel. Next, Parallel.For. It executes a parallel version of traditional C# for loop, distributing iteration across available resources. Finally, we have Parallel.ForEach. It executes a parallel version of traditional C# for each loop. Now we need to keep one thing in mind. So each of these methods seamlessly manages synchronization and completion, ensuring a block execution until all tasks are finished. That's what I have written note over here. All three methods block until all work is complete. Parallel.Invoke. Parallel.Invoke is a static method of parallel class. It initiates the execution of an array of delegates concurrently. It has two signatures. Signature number 1, Parallel.Invoke param action array action returns voids. So this signature allows you to invoke a set of action concurrently without specifying any additional option. So it takes a variable number of action delegates as parameters, allowing you to pass multiple actions to be executed in parallel. After invoking the action, it does not return any specific result. That's what I have written over here, returns void. It simply executes the action concurrently. So this signature is straightforward and convenient when you don't need to customize the parallel execution behavior. Now come to the second signature. Parallel.Invoke parallel option param action array action returns void. So this signature provides more flexibility by allowing you to specify additional option for parallel execution using a parallel option object. What I have written, first parameter parallel option, right? So the parallel option parameter allows you to configure various aspects of the parallel execution, such as setting a cancellation token, adjusting the maximum degree of parallelism, or even specifying a custom task scheduler. You can still pass multiple action delegates as parameters, just like in the first signature shown over here, right? So here, as a part of second signature, we are going to pass multiple action delegates as parameters, right? So after invoking the action with a specified option, it also does not return any specific result. That's what I have written here also, returns void. It executes the action concurrently based on the provided option. That's what the signature Parallel.Invoke does. Now let's understand Parallel.Invoke with the help of examples. Imagine you are throwing a big dinner party and you want everything to be ready at the same time. From cooking to the main course to setting the table, you could assign each task to a different friend and hope they all finish at the same time. That's kind of like what Parallel.Invoke does in C#. So here, imagine each task has a different aspect of party preparation. Here I have written Parallel.Invoke. Inside that I have written task number 1, cooking the main course. Then task number 2, setting the table. Task number 3, decorate. Task number 4, prepare appetizers. Right? So if you see technically what we have done, so here inside the Parallel.Invoke method, there are 4 anonymous functions, or we can say the delegates, provided as parameters like cook main course, set table, decorate, and prepare appetizers. Each anonymous function represents a separate task to be executed concurrently. So that's what we are going to achieve this. All these methods be executed concurrently with the help of Parallel.Invoke method. We can also write in a split way. The split way in the sense here, what I am doing first, we are going to creating an array of the action delegates. That's what I have written. Action array action is equal to new action. And here I have mentioned all the tasks: cook main course, set table, decorate, prepare appetizers. So basically what we have done, we have created an array named of action of type action array, where each element in this array is the action delegate, representing a method that takes no parameters and returns void. And that's how we have written like this. Then what I am doing, I am just invoking the task in parallel using Parallel.Invoke. That's what I have written, Parallel.Invoke. Here I am just going to pass this action. An action is nothing but the array of action delegates, right? Please notice the first signature. So this is the first signature. What we have done, we have created this action array separately, and in this invoke method I am passing that particular array of action. Basically I have splitted this code snippet in two steps. First, we are going to create an array of action delegates, and then whatever the array of action delegates we have created, we are passing into this invoke method as a input parameter. So the first way and the second way both are representing the signature number 1. Okay, let's switch to the Visual Studio and see all these things in action. Okay, so here we are on Visual Studio. Here we are going to see the demo of the Parallel.Invoke. So for that, what I have done, I have created one console application named Parallel class demo that has program.cs file. In program.cs file, first of all, I have included this namespace using system.threading.task. Then there is a class named program that has main method, which is an entry point of this application. Here I have printed this statement into console window with the help of console.writeLine, Parallel.Invoke demo, right? Then I have considered one scenario for which I have written this program. So what is the scenario? Let's imagine you are throwing a big dinner party. You want everything to be ready at the same time, from cooking the main course to setting the table. You could assign each task to a different friend and hope they all finish at the same time. So that's how we just incorporated all those concepts in this C#. How we are going to achieve that. Here I have written Parallel.Invoke, and here I have written 4 anonymous function or delegate, we could say, that provided as parameters like cook main course, set tables, decorate, prepare appetizers, right? So these are going to get executed concurrently. That's what the job is for the Parallel.Invoke. This is the one way we are going to write it. Second way we have written this way, that will be executing after showing this demo to you. Okay, then what I have done, once everything gets completed, I just wanted to print this statement: all tasks completed, dinner party ready. Now let's have a quick look what this task is doing: cook main course, set table, decorate, prepare appetizers. So we will see one by one. So here if you see cook main course, it is nothing but the static method that is returning nothing. That's what I have written, return type as a void. So in this cook main course, first whenever this method is going to get called, I am just printing this statement into console. In progress, chef is cooking the main course, and task delay 3000 dot wait. Basically I am just simulating cooking time over here with the help of delay method. When the delay is over, when the main course is ready, I am just writing this statement: console.writeLine completed, main course is ready. That's what this cook main course method is doing. Then set table. Again, whenever this set table method is going to get called, I'm just printing this statement: in progress setting the table, and I'm just making delay. So basically I'm just simulating table setting time with 2 seconds. Then console.writeLine statement, I have written completed table is set. When it is set, then I'm just printing this statement. Then decorate. Similarly in decorate method, again I'm just printing this statement: in progress decorating the dining area. Then I'm making the delay for 4 seconds. That's what I have written, task delay 4000 dot wait. Basically I'm just simulating the decoration time. Once it is done, then I'm printing this statement: completed, dining area is beautifully decorated. Then final method we have prepare appetizers. So here I have written this statement: in progress preparing appetizers. Then I'm making delay for 2.5 seconds. Then finally I'm just printing this statement: completed, appetizers are ready. That's how this program is designed. Okay, so let me go and execute this program and show this output to you. Okay, output started appearing. If you see, Parallel.Invoke demo got printed, scenario preparing for big dinner party got printed. And if you see, all these 4 anonymous methods started execute. That's what this statement got printed: in progress, chef is cooking the main course; in progress setting the table; in progress decorating the dining area; in progress preparing the appetizer. As soon as this task gets completed, we are just printing this state: completed, table is set, appetizers are ready, main course is ready, dining area is beautifully decorated. When every task gets completed, then only we are going to print this statement, all tasks completed, dinner party ready. As you remember, I have already mentioned that Parallel.Invoke will wait all tasks to get completed. Then only this process is going to get completed. That's how this all thing get completed. Then this statement got printed. All tasks completed, dinner party ready. Now let me comment this line and uncomment this line. Okay, so here basically I have splitted this code snippet in two sections. First, I'm creating an array of action delegates. That's what I have written, action array, action is equal to new action array. And here I have mentioned all the tasks, cook, main course, set table, decorate, prepare appetizer. Basically, I have created an array of action delegates. Then I'm invoking the task in parallel using Parallel.Invoke. Here I have passed this action, an argument over here in this Parallel.Invoke. So this is first way. This way we have already shown you. Same output we are going to get it from these way also. Let me go and execute this program. Okay, so output started appearing. If you see, all these things got printed accordingly. So we have seen both way. Either we are going to directly call this Parallel.Invoke with the anonymous function itself, where we are just mentioning all the four anonymous function, or we can say as a delegate, or we can create an array of action delegates separately and then passing as an argument in the Parallel.Invoke method. We are going to get the same output. That's the demo of Parallel.Invoke. Parallel.For. Parallel.For is a static method of Parallel class. It is designed to execute a loop in parallel, splitting the iteration across multiple threads to utilize the available processing power efficiently. Currently, it has 12 signatures. Here is its simplest signature. Parallel.For int from inclusive, int to exclusive, action int body returns parallel loop result. If you see its parameter from inclusive, it specifies the starting index of the loop, which is inclusive. Next, we have int to exclusive. What does it mean? It specifies the ending index of the loop, which is exclusive. Then we have action int body. It represents the actions to be performed on each iteration of the loop. It's a delegate basically that takes an integer parameters representing the current iteration index. Then we have parallel loop result. So this is the return type of the Parallel.For method. It provides the information about the outcome of the parallel loop execution, such as whether the loop completed successfully or was stopped prematurely. Okay, so let's understand it with the help of examples shown over here. Here I have written sequential for loop. For int I is equal to 0, I less than 50, I plus plus, then my function I. What does it mean? Here I have written a standard loop written in sequential fashion, meaning that each iteration executes one after the other in sequence. So this line, for int I is equal to 0, I less than 50, I plus plus. So this line declares a variable I, sets the initial value as 0. The loop will continue as long as I is less than 50, and after each iteration I is incremented by 1. That's what I have written I plus plus over here. Inside the loop, I have called this my function and I have passed the parameter as an I. So basically, this my function is going to get called for each value of the I. So here, my function I represents some function or method that takes an integer parameter. That's what this sequential for loop is doing. Now, let's parallelize using Parallel.For with the lambda expression. So I have written Parallel.For 0, 50, I goes to my function I. So here Parallel.For is a method provided by the parallel class in C#, right? So it initiates a parallel loop. So what is loop range over here? Here I have mentioned the first parameter is a 0. It specifies the starting index of the loop, which is inclusive. Second parameter I have mentioned over here 50. It specifies the ending index of the loop, which is exclusive. This means that the loop will iterate from 0 to 49. Then we have third parameter I goes to my function I. So it represents the action to be performed on each iteration of the loop. Now let's have a look parallelize using Parallel.For with method group conversion. So here again I have written this thing Parallel.For 0, 50 my function. So here the first parameter again 0 over here that specifies the static index of the loop, which is inclusive. The second parameter is 50 that specifies the ending index of the loop, that is exclusive. This means that loop will iterate from 0 to 49 over here also. Then we have the third parameter, which is nothing but the method reference. It's the name of the method that will be called on each iteration of the loop. That's what I have written my function, which is nothing but the method reference over here. So this Parallel.For executes the loop iteration concurrently, distributing them across multiple threads. Okay, so now you have understood how we are going to use the Parallel.For in both way, whether it is going with the lambda expression or it is going with the method group conversion, right? Okay, so let's switch to the Visual Studio and see all these things in action. Okay, so now we are in Visual Studio. Here we are going to see the demo of the Parallel.For demo. For this, I have created one console application in Parallel class demo that has program.cs file. There is a class named program that has main method, which is an entry point of this application. First of all, in this method, what I have done, I have just printed this statement console window with the help of console.writeLine state Parallel.For demo, right? Then I just written one sequential for loop in the traditional way. First of all, I'm just writing this statement using sequential for loop. Here I have written for int I is equal to 0, I is less than 50, I plus plus, and my function I. So this is the traditional way how we write this for loop, right? Where we have the initialization, then we are checking the condition. If it gets satisfied, then this loop is going to get proceed, otherwise it's going to get terminated. And this is something we are just going to increment the value of the I. So I plus plus I have written because I am just want to increment by 1, right? And then for each int, this function is going to get executed, right? My function I. Let me show you what this my function I does. My function I basically a static method that is returning nothing. That's what I have written void over here. Is going to accept int data type. That's what I have written int I. And then what this method is doing, it is just printing this statement into console window, square of I into I. Basically I am just printing value of a square of this particular int value, right? That's what I have written, square of I into I. That's what this my function is doing. Now come to here, this is something we have written sequential for loop. Then what I have done, I have written parallelized using Parallel.For with the lambda expression. So I have written this statement Parallel.For 0 comma 50 comma I goes to my function I, right? Here I have mentioned the first parameter 0 that basically specifies the starting index of the loop, which is inclusive. And then second parameter 50, it specifies the ending index of the loop, that is exclusive. And here I have written I goes to my function I. Basically it represents the actions to be performed on each iteration of the loop. So this is nothing but the lambda expression. So basically this lambda expression taking a single parameter I, which represents the current iteration index. Inside the lambda expression, I have used this my function, right? I is called. Basically here I am passing the current iteration index I as an argument to the my function. And this iteration is going to again call this my function method for each and every int value, right? So that's what I have written this Parallel.For loop with the help of lambda expression. Now another way of writing a Parallel.For loop with the help of method group convert. Here what I have done, I have written again the first parameter 0, second parameter is 50. Here I have written directly the function name. That's what I have written my function. It will be performed on each iteration of the loop. So here nothing, my function is nothing but the method reference, the name of the method that will be called on each iteration of the loop. Basically this Parallel.For execute the loop iteration concurrently, and it is distributing them across multiple threads, right? So let me go and execute this program. Okay, so output has started appearing into this console window. If you see, Parallel.For demo got printed using sequential for loop, square of 0 0, square of 1 1, square of 2 4. Please notice all this square operation is getting performed in a sequential fashion. That's what this for loop basically executes in the sequential manner. That's what if you see 0 1 2 up to 49, it just executed in the sequential fashion. Now let's see how Parallel.For is going to get performed with the help of lambda expression. Square of 0 got printed 0, square of 6. You see here all these are not in the sequential fashion. Basically it will be getting executed by the different thread. That's what you are not able to see in the sequential fashion, right? So it started with 0, then 6, then 1, then 2, and it got ended in 41. In between, if you see, 49 got printed, right? Here 49 got printed. So it is not in the sequential fashion, but Parallel.For is going to give me much more performance. It is going to get executed quickly because it is going to be handled by different. Now if you see the parallelize using Parallel.For with method group conversion, here also it is not in the sequential fashion, right? Square of 0 0, square of 1 1, square of 6 36, square of 12 144, and list goes on. until it performs up to 49, but it's not going to get performed in the sequential fashion, right? Because it is going to get handled by the different thread. That's how different thread handle this, process this, and that's how this output going got printed. So that's the way how we are going to use this Parallel.For for processing the items in the concurrent fashion. Parallel.ForEach. Parallel.ForEach is also a static method of parallel class. It provides a convenient way to iterate over a collection such as an array or list in parallel. Currently, it has 20 signatures. Here is its simplest signature. Parallel.ForEach T source, IEnumerable T source, source, action T source, body returns parallel loop result. So if you see this T source, what is T source meaning over here? It represents a type parameter allowing the Parallel.ForEach method to work with any type of elements in the source collection. Then if you see these parameters, IEnumerable T source, what it does, this parameter represents the source collection over which the loop will iterate. It's an IEnumerable T type, meaning it can be any collection that implements the IEnumerable interface. Then we have action T source body. This parameter represents the action to be performed on each element of the source collection. It's basically a delegate that takes an element of the type T source as a parameter and returns void. Now come to the return part of the Parallel.ForEach method. It returns the parallel loop result. So this parallel loop result, it gives the information whether the loop completed successfully or was stopped prematurely. So overall, the Parallel.ForEach method initiates a parallel loop that iterates over each element in the source collection. For each element in the collection, the specified body action is executed with the current element passed as an argument. Internally, what this Parallel.ForEach does, it distributes the loop iteration across multiple threads, allowing for concurrent execution of the loop iteration. Okay, let's understand with the help of examples shown over here. Here, I have written sequential for each loop. For each char C in Learn and Njoy, triple dot. Then inside this for each loop, I have written my function C. It means that each iteration executes one after the other in sequence. And if you see this statement, for each char C in Learn and Njoy, so this line initializes the loop. It iterates over each character in the string learn and njoy triple dot one at a time. In each iteration, variable C is assigned the value of the current character being iterated. Inside the loop, what I have done, I have called this my function C for each character. So here, my function represents some function or method that takes a character parameter C over it. Now, if you see its parallel version, here I have written parallel form of for each loop using Parallel.ForEach. Here what I have done, I have written Parallel.ForEach learn and njoy triple dot comma my function. So here Parallel.ForEach is a method provided by the parallel class in C# that we have already known, right? It initiates a parallel loop for iterating over elements in a collection. So here the first parameter learn and njoy triple dot represents the source collection over which the loop will iterate. In this case, it's a string, right? And the second parameter my function represents the action to be performed on each element of the source collection. So here my function is nothing but a method reference. It's the name of the method that will be called on each element of the source collection. So overall, this Parallel.ForEach executes the loop iteration concurrently, distributing them across multiple threads. So each thread processes a subset of the loop iteration simultaneously, potentially leading to improved performance, especially on multi-core processors. Now you have understood how this Parallel.ForEach going to be executed or how we are going to write it, right? Okay, so let's switch to the Visual Studio and see all these things in action. Okay, so here we are on the Visual Studio again. Here we are going to see the demo of the Parallel.ForEach. For that, we have created one console application in Parallel class demo that has program.cs. First of all, I have added necessary namespaces over here. System using system.threading.task. Then there is a class named program that has main method, which is an entry point of this application. Here, first of all, I'm just printing this statement into console with Parallel.ForEach demo, because I'm just giving the demo on this concept. First of all, what I have done, I have written sequential for each loop. Console.writeLine using sequential for each loop, I'm just printing, and then I have written for each loop. Char C in learn and njoy. Then inside this for each loop, I'm just calling this my function C. Why I have written? Because I just want to give you feel how we are going to write this parallel way, similar type of for each loop, right? So here, if you see, same concept I have applied into with the help of Parallel.ForEach. See, I have written Parallel.ForEach, and here I have written the source content learn and njoy, which is nothing but the string over here, and then I have written my function. So my function basically it is going to be performed on each element of the source collection. What is the source collection? This one, right? And this Parallel.ForEach is basically is going to return this parallel loop result as a runtime. Right now we are not using over here, but usually it returns that. If you want to capture, we can capture it and we can process it further, whether the loop has successfully completed or it was stopped. What the output we are going to receive with this, we are going to receive with this one also, but in a parallel way. Okay, so if you see this my function is nothing but a static method that basically accepts input parameter as a character, and then it is just printing this character into console window. That's what this my function method. Let me go and execute this program and show this output. Okay, so output got appear into this console window. See, Parallel.ForEach demo got printed using sequential for each loop, and here if you see, all this character got printed, character L, E, it got printed in the sequential fashion. That's why I'm saying that for each loop, the traditional way, it performs in the sequential fashion. This character got printed in a sequence, and we are going to process this content with the help of Parallel.ForEach. It is not going to perform in the sequential fashion. That's why you see this character L got printed, then character A, character O, character Y, then triple dot got printed, and E, space got printed, and space got printed, and JR got printed. It's not in a sequential fashion. But the benefit is that Parallel.ForEach employ this task into various threads, and it is going to perform for us. So it will save the time and it improves the performance. Okay, that brings me to end of my session. To sum up, in this video, we explored the parallel class and its trio of static method, Parallel.Invoke, Parallel.For, and Parallel.ForEach. Through various examples, we gained insight into how these methods work and their practical application. By now, you should have a clear understanding of the parallel class, its functionality, and how it can effectively address concurrency challenges. That's all for this video, guys. If you like this video, hit the like button, share it with your friends and colleagues, subscribe to my channel if you haven't done already. Thanks for watching. See you next video.